In section 2.6, you're going to be working with transformations, and today we're just going to do translations and reflections. So let's just go over again what a translation is. Translations are slides. They move a function up, down, left, or right. And a reflection is a flip. So it flips a function over the line of reflection. Now, transformations with points, we started out doing in chapter 1 before we went to functions, so we're going to just review that again. Now, when you have a point, you want to see what the change is. If you're doing a transformation, does it affect the x or does it affect the y? Well, what I'm going to do, this is 0.23, so here's the 2, here's the 3. This plus 4 is the transformation because it wasn't over here. So we need to decide first if it's horizontal or vertical. And just a reminder, if you put x and y in alphabetical order and horizontal and vertical in alphabetical order, it lines up. Horizontal is always left or right, and vertical is up or down. Okay, so since the change is happening to the x, we say that it's horizontal. And because we're adding, it's going to be a translation. And we're adding 4, so it's going to go to the right 4. Now, the next one I'm just going to have you put a negative sign in front of that 5, just so we're only dealing with one transformation. So negative 5, 7, 7. The minus 2 was not here, so that's the transformation that's taking place. And because it's affecting the y, it's going to be vertical. So it's a vertical translation. And if we're subtracting 2, it's going to go down 2. Now remember I mentioned that transformations were all about location, location, location. That will indicate if it is horizontal or vertical, and also operation, operation, operation. That will determine if it is a stretch, compression, or a translation. So let's go to example 1. We are going to just work right now with transformations. So with transformations that are translations. So with translations, you're going to add or subtract. That's how you know that it's a translation. Okay, now we're starting with this original function. So usually when you start with a function, the original function, you name it f of x. So let's go down here and see what's changed. F of x is 3x squared. Now we have g of x. Now g of x you usually use to identify that it's a transformed function. So it's changed from f of x. You start with f of x, you make some kind of a change, and you call it g of x. Okay, well we have 3x squared. So what I'm going to have you do is highlight everything except 3x squared with that function. So I have a minus 1 here, and I have to identify what that is. Now, when we were in chapter 1, I talked about the horizontal house. The horizontal house is when you put parentheses around the x, and the x is inside, and there's a change inside. So you're either, if it's in the horizontal house, it's horizontal. If it's not, it's vertical. So it can only be one of two things. So this is not in the horizontal house. So that makes it a vertical. And because it's a subtraction, it makes it a translation. And we're going to go down 1. Okay, now, I'm going to caution you once again that horizontal translations do not, so circle that, underline it, star it, whatever you need to do to remind you that horizontal translations do not behave the same with functions as they did with points. So let's look at this. Now remember, I called this the horizontal house of horrors, and the H-O-R-R-O-R-S. And the reason why I call it that is because the numbers inside do not behave like you think they do. So what happens is when we have a number inside the horizontal house of horrors, we have to it says minus 1, but we're going to think plus 1. So we take it to the opposite. So for that reason, this is a horizontal translation. But it says minus 1, we think plus 1, so that means it goes to the right one. Okay, now we're going to move on to reflections. With reflections, we take the opposite, so that's an operation. All right, so same thing here. Highlight anything that's not 3x squared, so that would be this negative and this negative here. I kind of got the x there, but just pretend that that's the negative. All right, so let's go down to this one right here. We're taking the opposite of x. Well, let's remember what happens when we do a reflection over a line. If this point is 2, 1, and I reflect it over the x-axis, it becomes 2, negative 1. Now we reflected over the x-axis, but the y went to the opposite. So let's look what's happening with this one right here. I'm taking the opposite of x, so that means it's going to reflect over the y-axis. Now, early in the year, we talked about we can write f of x equals 3x squared. I can replace this with y equals 3x squared. So when you're dealing with transformations and you want to affect the y, it's the entire side. So this is y. So for that reason, when the whole side is in parentheses, the negative is on the outside, you're taking the opposite of y, which means that it reflects over the x-axis. Okay, let's go to the next example. We're using, this is our beginning function, f of x equals 2x plus 3. We want to write the rule. So here we had the rule, so they're calling the functions the rules. We had the rule and we had to identify the transformation. Now we're going to go the opposite way. We have the transformation and we need to write the rule. Okay, so remember, location, location, location. Wherever you put the transformation depends if it's vertical or horizontal. So here I see vertical. Vertical means it does not go in the horizontal house. So I start out by writing g of x because I know it's a transformation. And I can just tack a vertical translation right onto the end. So this is going to be g of x equals 2x plus 3. And I want to go down 3, so I'm just going to subtract 3. With vertical translations, what you see is what you get. Now we're going to simplify this and make it g of x equals 2x because positive 3 minus 3 just gives us 0. Now I want to reflect over the x-axis. Okay, so if I want to reflect over the x, look what happened back up here with our graph. I took the opposite of y. So we're going to take the opposite of y, which is the entire side. Okay, so we're reflecting across the x-axis, so I'm going to take this function here. I'm going to write g of x because it's a transformation. I'm going to take the opposite of the entire side. So please put this in parentheses because I don't want you just to say negative 2x plus 3. You take the opposite of everything. So this is going to simplify to g of x equals negative 2x minus 3. Okay, now we want to do a horizontal translation 1 unit to the right. Okay, so we have g of x equals, because it's horizontal, it has to go into that little house, the horizontal house, with just the x and the translation. So as I write the function 2, when I get to the x, I put it in parentheses, I put it in the horizontal house, and then I have to write the plus 3 out here. Okay, now what happens in the horizontal house? If it's to the right, usually you would go in the positive direction, but because it's in the horizontal house, we have to do the opposite. So instead of adding 1, we subtract 1. And then we can simplify by distributing, so 2x minus 2 plus 3, and g of x is going to equal 2x plus 1. And that's our final answer. Okay, now we're going to do a reflection over the y-axis. So the y-axis, we take the opposite of x. So when we write that function, g of x equals, we're starting out with 2. We take the opposite of just the x and then add 3. So when we simplify, we have g of x equals negative 2x plus 3. And there's your final answer. Okay, you have a few problems to try on the other page.